This is my tutorial on question 1 in my question section, and I'll walk you through how to do each step. So question 1 states a particle moves on the x-axis so that its position at any time t greater than 0 is given by x of t equals 2te to the negative t. So part A asks to find the acceleration of the particle at t equals 0. So we know that the acceleration of any particle is the second derivative of the position function. So we take the second derivative of x of t and we get a of t. And a of t equals 2t minus 4 times e to the negative t. Now part A wants the acceleration at a specific time t equals 0. So we plug in 0. So a of 0 equals 2 times 0 minus 4 times e to the negative 0, and we get negative 4 is the acceleration at t equals 0. Now part B asks us to find the velocity when its acceleration is 0. So first we need to find out when the acceleration of the particle is equal to 0. So we set our acceleration function to 0 and we solve that and we get x equals 2. So now we know when the acceleration is equal to 0, so we can plug that into our velocity function. Now when we took the second derivative of the position, we also took the first derivative, so we get v of t. So v of t equals 2 minus 2t times e to the negative t. So what we do is we plug in 2 and we solve, and we get v of 2 equals negative 0.270671, and we round to the thousandths and we get v of 2 equals negative 0.271. Part C asks us to find the total distance traveled from the particle t equals 0 to t equals 5. So we have our limits 0 and 5, and we have to take the integral of the velocity formula. But since it's total distance, we have to take all positive values. So we take the absolute value of v of t. So we set up the integral. Then we have the integral from 0 to 5 of the absolute value of 2 minus 2x e to the negative x, and we get 0.067379, which is rounded to 0.067. And that's tutorial on question 1. Thanks.